everyone, my name is Shafika. Our project is a web-based video streaming platform. This platform allows users to stream digital content such as movies, television series, documentaries, and educational videos directly through a web browser. The purpose of developing this platform is to provide users with convenient access to online entertainment without requiring additional software installation. Users can access content anytime and anywhere as long as they have an internet connection. The system focuses on delivering a user-friendly, secure, and efficient streaming experience. The project is guided by 6 major objectives. First, we aim to ensure security and reliability by implementing strong authentication mechanisms, encrypted communication, and resilient infrastructure. Second, we want to provide high-quality video playback with minimal buffering and smooth streaming performance. Third, the platform will feature an intuitive and user-friendly interface, making navigation and content discovery simple for users. Fourth, we will support cross-device accessibility, ensuring compatibility across desktop, laptop, tablets, and mobile devices. Fifth, we will maintain effective project governance, ensuring that cost, schedule, and quality remain under control throughout development. And finally, we seek to maximize user satisfaction, encouraging engagement, retention, and positive user experience. The project scope is divided into 2 main areas. First, the front-end scope and the back-end scope. The front-end scope focuses on user-facing features. These include user registrations and login, video playback controls, content search and recommendation function, subscription management, and responsive design for multiple devices. The back-end scope handles system operation behind the scene, which includes database management, video storage and processing services, authentication and access control, payment gateway integration, analytics reporting, and system maintenance support. Together, these components create a complete end-to-end streaming solution capable of supporting both users and administrators effectively. To manage project development efficiently, we have chosen the Agile software development methodology. Agile divides development into smaller iterative cycles that call sprints. This allows the team to continuously deliver working features and gather stakeholder feedback throughout the project. Another advantage of Agile is continuous testing, where testing activities occur during every sprint instead of only at the end of development. Agile also promotes strong team collaboration, encouraging regular communication between developers, designers, testers, and stakeholders. Finally, Agile supports adaptive planning, allowing the project team to respond quickly to changing requirements and user needs while maintaining project quality. The project timeline spans a total of 20 weeks and is divided into 6 phases. The first phase is requirement analysis, lasting 2 weeks, where all businesses and user requirements are collected and documented. The second phase is system design, lasting 3 weeks, focusing on architecture design, database structure, and interface wireframe. The third phase is development, which takes 8 weeks and represents the largest portion of the project. During this phase, both front-end and back-end components are built using Agile sprints. The fourth phase is testing, lasting 3 weeks, where functional, performance, and security testing are conducted. The fifth phase is deployment, lasting 2 weeks, where the system is launched into the production environment. And finally, the maintenance phase, that lasts 2 weeks and focuses on performance monitoring, bug fixes, and system stabilization. This structured schedule helps ensure timely project delivery and quality outcomes. To produce a realistic and reliable budget, we apply 3 different cost estimation techniques. The first technique is analogous estimation, which uses historical data from similar streaming and web application projects as a reference. The second technique is bottom-up estimation, where individual project activities are estimated separately and then combined to form the total project cost. The third technique is 3-point estimation, which considers optimistic, most likely, and pessimistic cost scenarios to account for uncertainty and risk. By combining these techniques, we improve estimation accuracy, support better resources planning, and reduce the likelihood of budgets overrun. The total estimated project cost is 185,000. The largest allocation is back-end development with 42,000, covering APIs, video processing, streaming services, and core infrastructure. The second largest component is other expenses, totaling 37,000, which include maintenance, contingency reserve, and operational costs. Front-end development accounts for RM 35,000, supporting interface development, playback features, and responsive design. Additional allocation include UI/UX design, cloud hosting setup, database development, testing and quality assurance, as well as security implementation. This budget distribution reflects the technical complexity of building a secure and scalable streaming platform while ensuring sufficient investment across all critical project components.
Assalamualaikum and hi, I am Nurul Ainadira. I will explain cost budgeting, cost control, and EVM calculations. For cost budgeting, the total project budget is 185,000 and is distributed across 6 phase projects over 5 months. The largest allocation is for the development phase, which received 92,000 as it involves front-end and back-end development, streaming feature subscription systems, and the admin dashboard. So we can see the table that requirement analysis costs 12,000 ringgit for month 1, week 1 and 2. System design require 80,000 ringgit for week 3 and 5. Development require 92,000 for week 6 until 13th. For testing, it requires 12,000 ringgit for week 14 until 16th. And the deployment phase requires 41,000 for week 17 and 18. And the maintenance requires 10,000 ringgit for weeks 19 to 20. This budget distribution serves as the project cost baseline and supports earned value management or EVM monitoring. To monitor project performance, we use earned value management or EVM. The main metrics are PV, plant value, EV, earned value, AC, actual cost, CPI, cost performance index, and SPI, schedule performance index. At month 3, the project should have achieved 60% completion, but only 45% was completed. The actual cost spent was 19,000 ringgit. As we can see in the table, the project manager requires 19,500 ringgit, front-end developers requires 42,000 ringgit, UI/UX designer requires 80,000 ringgit for 2 months only, cloud hosting requires 2,400 ringgit, software license requires 3,500 ringgit, security tools requires 5,000 ringgit, testing and QA requires 0 ringgit, miscellaneous and other expenses requires 13,600 ringgit. So the total actual cost is 97,000 ringgit. Before we start the calculations, earned value management (EVM) is a proven project management technique used to measure project performance in terms of cost and schedule. It helps determine whether a project is on budget and on schedule. For this project, BAC budget at completion 185,000, actual cost 19,000 ringgit, plant progress 60%, and the actual progress is 45%. First, we compute the earned value EV. EV equals to percentage of work completed multiplied with BAC. So EV equals to 45% multiplied with 185,000. The answer is 83,250 ringgit. So value of completed work is 83,250 ringgit. Next, we calculate the cost variance. CV equal to EV minus AC. So 83,250 ringgit minus with 97,000 equals to minus 13,750 ringgit. The project is over budget by 13,750 ringgit. Next, we calculate the schedule variance. The formula is SV equal to EV minus PV. So PV is 60% equal to 185,000 equals to 111,000 ringgit. SV equals to 83,250 ringgit minus 111,000 ringgit equals to minus 27,750 ringgit. The project is behind schedule because actual cost progress is lower than planned. Next one is CPI. Formula is CPI equal to EV divided by AC. So CPI is 83,250 ringgit divided by 97,000 equals to 86 cents worth of work is delivered. So the project is over budget. Next, we calculate schedule performance index. SPI equal to EV divided by PV. So SPI is 83,250 ringgit divided by 111,000 ringgit. We get 0.75. Means only 75% of planned work is completed. So the project is behind schedule. Next, we calculate estimate at completion EAC. EAC equals to BAC divided by CPI. EAC equals to 185,000 ringgit divided by 0.86. So we get 215,116 ringgit and 28 cents. If performance continues, the project cost will exceed budget. Next, we'll compute variance at completion VAC. VAC equals to BAC minus EAC. So VAC equals to 185,000 ringgit minus by 215,116 ringgit and 28 cents. We will get minus 30,116 ringgit and 28 cents. Interpretation: the project will exceed budget by 30,116 ringgit and 28 cents. So we can see the table here, the summary of the calculation. So we can see that the cost variance is over budget. The schedule variance is behind schedules, CPI, poor efficiency, and SPI, schedule delay, while the VAC there is budget gap, and EAC overrun. The project is over budget and behind schedule. Immediate corrective action is required to recover costs and schedule performance. While based on the EVM analysis, the project is facing both cost and schedule issues. CPI of 0.86 indicates the project is over budget, while SPI of 0.75 indicates the project is behind schedule. The forecasted total cost is 215,116 ringgit and 28 cents, which exceeds the approved budget of 185,000 ringgit by about 30,000 ringgit. Therefore, immediate corrective action is required to bring the project back on track. To improve project performance, several actions are recommended. First, reduce unnecessary expenses to improve budget efficiency and increase CPI. Second, increase development resources to speed up progress and improve SPI. Third, conduct regular monthly monitoring to detect deviation early. Finally, implement stricter change control to avoid unplanned costs and delays.
Next is response recommendation. Immediate action is taken to reduce unnecessary costs and improve cost performance index. To recover the project baseline, a cost optimization plan is executed. Step 1. Identify unnecessary costs. From month 3 expense review, software license were underutilized, cloud hosting capacity exceeded actual needs, and miscellaneous expenses increased due to unplanned costs. Step 2. Implement cost reduction strategy. Open source tools are used such as Visual Studio Code instead of paid IDE and PostgreSQL instead of paid database system. Cloud hosting is optimized based on actual usage. Testing is automated using Selenium or Jest to reduce QA costs. Labor cost is controlled by limiting overtime and improving task allocation. Step 3. Recalculate CPI after cost reduction. Actual cost is reduced from 97,000 ringgit to 88,000 ringgit. EV remains 83,250 ringgit. New CPI equal EV divide AC equal 0.95. The CPI improved from 0.86 to 0.95, showing better cost efficiency and bringing the project closer to the planned budget. This strategy should continue in remaining space to achieve CPI close to or above 1 and improve overall project performance. Now, I will conclude the presentation by summarizing the key findings of our project. For this project, we successfully applied software project management principle in the development of the web-based video streaming platform. We established clear project objective with a total budget of RM185,000 and develop a secure, scalable and user-friendly streaming platform. Based on our end value management analysis, the project was initially found to be over budget and behind schedule. This can be seen from the CPI of 0.86 and SPI of 0.75. In addition, the EAC indicated a potential budget overrun if no corrective action was taken. To address this issue, we implement several cost optimization strategies. As a result, the CPI improved from 0.86 to 0.95, demonstrating better cost performance and more effective project management. Moving on to the key takeaways, continuous monitoring is essential for tracking project progress and performance. Effective resource management helps improve productivity and ensure resources are utilized efficiently. We also learned that strong change control is important to prevent unnecessary cost increase and schedule delays. Furthermore, cost optimization should not be treated as a one-time activity but should be continued applied throughout the project life cycle. Finally, proper planning, realistic budgeting, and regular performance evaluation are critical for delivering projects on time, within budget, and at the expected quality level. Thank you.